Good morning, everybody. This is a live Code Red severe weather briefing, as it looks like that isolated tornado threat in severe weather zone is going to set up between about Houston and the Austin, Texas area. I've got my new microphone here that should be improving my audio quality a little bit, and I'm going to turn on the Code Red mode here, as this definitely has a legitimate tornado threat despite relatively marginal thermodynamics and even some marginal low-level wind shear. Those are the things that I'm definitely noticing. But what's going to be the difference maker is this really potent vortmax here. This is the NAM forecast for about 0Z this evening. That's about 6 p.m., exactly 6 p.m. Central Standard Time. And that is an incredible bowling ball of a vortmax here. And we're going to see the remarkable transformation from having that backside loaded trough, basically potential vorticity streaming down the backside of this trough, and then it rounds the base of that trough. You have cyclonic curvature, also speed shear there, major vorticity realization there on the base of the trough, and that happens between about noon and 0Z tonight. So over that 6-hour period, that flow on the backside of that trough over eastern New Mexico rounds the base of the trough here. You get a big ramp up of that vorticity in the mid-levels of the atmosphere. You get a lot of vorticity advection downstream. You get the formation of a surface low, the development of a modest low-level jet. So you get about 30 knots a kilometer above the ground there out of the southwesterly direction, and that's going to generate just enough wind shear for a marginal tornado threat down near the Houston area, west toward Austin, especially west of Houston. It does look like some of that moisture could be a bit marginal. Houston and off to the east, that's what many of the short-range models are showing. And last night, I created this target area here. This is the target area from last night. Notice that I kept it to the west of the Houston, greater Houston area. And that's because it looks like that moisture axis is going to surge just a little bit west of the Houston area, and it is modified moisture, definitely. So it is a pretty marginal thermodynamic environment, pretty marginal in terms of the low-level shear as well. But I do think that that severe weather threat is going to be out in this region, to the west of Houston, to the east of Austin, maybe a little bit further south than that, down in the northern portion of that risk area. And then it is possible that that convective line builds all the way down toward the Port Lavaca, Victoria area, with even some renegade supercells down in the southern portion of that. But again, as I mentioned, the timing of this needs to be perfect. The late arrival of the moisture, looking at the surface map, it looks like some of that moisture is a bit marginal, even through the afternoon hours. But this is a very potent vortmax. There's a lot of cold air aloft. That's going to help enhance those lapse rates. Definitely is going to be a lot of clearing as well. Photographs appear marginally conducive for a tornado threat, but very conducive for some photogenic supercells out there. But again, I think that this threat is probably going to remain to the west of the Houston area, and that eventually that convective line moves into Houston closer to about 6 p.m. And there's a chance that if some greater moisture can move in to the Houston area, that tornado threat could be a little bit higher. The slight risk this morning does include the Houston area, downtown Houston. That also includes that tornado threat there, or that 5% tornado threat that has been added to the Houston area. But I think that main tornado threat is going to focus just a little bit west of Houston, between Houston and the Austin area. That's the area that I'm definitely watching for the most favorable tornado threat today. And here is that responsible trough this morning. This is the trough that's leading to the severe weather. It's also the trough that's going to lead to the snow event across the southern Appalachians that I'm going to be covering. And that's going to be, it looks like western North Carolina, the Asheville area toward Brevard. Could easily be a 4 to 8 inch type snowfall, especially in the higher terrain above about 2,500 feet. But first, it's going to cause severe weather across south central Texas, likely just to the west of the Houston area. But this is the trough this morning, diving down through northeastern New Mexico, through the Texas Panhandle. Has a ton of flow here on the backside. You could call this a potential vorticity streamer here, surging on the south side, backside of this trough. That's how you know that this trough is maturing, digging down to the south, and then eventually all that flow rounds the base of the trough. You get that cyclonic curvature, and that's when this is going to develop into a very potent vortmax over eastern Texas through this evening. Exciting a modest low-level jet that's going to be borderline for that tornado potential. And the timing of this process, going from this backside-loaded trough to a trough that has that flow rounding the base, the timing of that is critical to determine that tornado potential. And there you can see the forecast for 0Z this evening. That's 6 p.m. Central Standard Time with that stronger flow rounding the base of the trough there. A lot of cyclonic curvature by this time. That's when you get peak vorticity advection downstream relative to this system right there. That's going to excite the low-level jet, with that low-level jet increasing slightly as we go through the day today. But notice how it also gains that more neutral tilt. This is a closed 500 millibar low. You can see those closed height contours there, and this strong flow wrapping around the south side of that trough. Notice the cyclonic curvature to the flow as it's turning to the left around that base of the trough. That's vorticity, and you can also generate vorticity through speed shear, and that says this subtropical jet that is draped across northern Mexico there, across the northern Gulf of Mexico. That enhances the cyclonic vorticity as well in the base of the trough. The subtropical jet is located a little bit higher in the troposphere as compared to the polar front jet stream, but still it can cause the generation of vorticity, enhancement of vorticity at the base of that trough, digging them even further. And that's why during El Nino years, when you have an energized subtropical jet like this, it can dig the troughs further south. You get a greater tendency for these closed 500 millibar lows, a more stagnant upper level system, and even some split flow across North America. And I'm starting to see characteristics of La Nina and El Nino with this pattern. You do have a jet way off to the north like this. You have a subtropical jet off to the south. You do have the tendency for these systems to close off and become stagnant. But at the same time, you have quite a progressive wave train across the country. You do have some La Nina-like patterns here with these systems coming into the Pacific Northwest here. Atmospheric river events pounding those areas in the Pacific Northwest, southern Canadian Rockies there. But then you start to get this more of an El Nino-like pattern. We also have some blocking over Greenland that's going to continue through this month that will increase the chances for southern U.S. snowfall. This system here is going to result in some potential snowfall Thursday night into Friday across the southeast. We're definitely going to have to watch that very closely. But right now we are focused on the severe weather of this. And here's the low-level jet I was telling you about. Notice how it's really modest so far this morning, and that's because that trough is still yet to mature. It has a majority of the flow on the backside, not a lot of vorticity advection downstream of it just yet, but that changes dramatically as that flow, that potential vorticity streamer on the backside of that trough whips around the base of the trough. You get a lot of cyclonic vorticity at the base of it, and really that vortmax matures as it rolls into eastern Texas. But this is at 12Z this morning, showing a modest low-level jet, 20 to 30 knots there. And it's really not reaching the deeper moisture, especially down further south in the Gulf of Mexico. That's because this wave is relatively late maturing. Right now, as it's diving south through the central Rockies, it doesn't really get its act together until it gets into the southern plains, but that's when that low-level jet is going to start to intensify due to the vorticity advection downstream as that flow rounds the base of the trough. There you can see that low-level jet increase just a bit across East Texas. This is at 6 p.m. So somewhere in between there, probably near 21Z at about 2, 3, 4 p.m., that's when the threat of tornadoes is going to be greatest, just to the west of the Houston area, between Houston and Austin. But this is that low-level jet that intensifies between this morning and this evening because of that potent vortmax. That flow whips around the base of it, increases the cyclonic vorticity advection downstream, and then you get the enhancement of those low-level winds about 1 kilometer above the ground. And we're going to break down the hodographs as well and the smaller scale meteorology. But first, I want to show you this in a vorticity manifestation of this trough. Here you can see this streamer really showing that this trough is backside loaded at this stage. You have a bit of a positive tilt at that trough axis. Here you can see the closed 500 millibar low at the base of it. And this streamer, this strong wind on the backside of this system is going to whip around the south side of this trough, and that's going to enhance the cyclonic curvature along the south side of that. It's really going to boost the vorticity advection downstream. That's going to lead to the formation of a surface low and the ramp up of that low-level jet downstream, just enough to get those photographs favorable for a tornado threat, especially to the west of Houston, but maybe near Houston by about 6 p.m. as well. But watch how this system transitions from that backside loaded system to more of a closed vort. Boom, look at that. And look at that bulbous vortmax gaining more of a neutral tilt as it ejects from the southern Rockies across the southern plains. Perfect timing for a severe weather event. So in terms of the kinematics, the upper level dynamics, this is perfect in terms of severe weather. And if you had just a little bit greater moisture down there, you'd probably be talking about a more substantial tornado threat. But with the late arrival of an already modified moisture profile, dew points are going to be largely in the lower 60s for this event, at least to the west of Houston. Might even be in the upper 50s near Houston. But with this bowling ball of a vortmax diving into eastern Texas, there's going to be a lot of cold air aloft, and that's going to lead to the potential of sufficient thermodynamics for even a tornado threat. Turn this mic up just a little bit. Need to get a little platform right here so it'll put the mic just even with my mouth, and then if I talk into it, it'll increase the quality of that just a bit downstream. But here you can see the surface map so far this morning showing relatively marginal moisture so far here, especially this even over the open Gulf of Mexico is showing mid-50s dew points, and that kind of shows you what we have to work with here. Over Houston, you see this flow that's a little bit more easterly like that. That's not going to help with the improvement of those dew points across the Houston area. Most of the dew points are back here, back toward Port Lavaca to the west of Houston. They are going to improve just a little bit. You could see some 62, 63, 64s lifting north just a bit as that low-level jet increases through the afternoon hours. But right now, so far this morning, because that trough is still maturing upstream with a lot of that flow located on the backside, most of that low-level jet is kind of up here across northern Texas. So it's not really digging down into these dew points yet and pulling those northward across the Houston area. If that happened, I would think that the severe weather threat across Houston, Galveston area would be more substantial later on today. But I think it's going to be more dependent on where these greater dew points line up, 63s and 64s. And we do have kind of a late development of that low-level jet as that vortmax matures and dives in to central and eastern Texas through the afternoon into the evening hours. So you are going to have a little bit of an improvement of these dew points, but based on forecast soundings, I think that a 62, 63 type dew point will probably get it done, and that'll result in sufficiently low cloud bases to get a tornado threat. There is going to be marginally sufficient wind shear as that low-level jet accelerates above 30 knots across this area. And I'm going to show you those photographs. A lot of that is due to the shape of the trough and those more veered middle and upper level winds, creating east-northeasterly storm motions and basically 90-degree critical angles on the photographs. And I'm going to show you how that wind shear is relatively favorable for the development of tornadoes. And there is going to be a convective line or a mesoscale convective system. You can already see some rain showing up here on the surface map near and just to the south of the DFW Metroplex. And really the south side of this complex of storms, that's where it's going to meet up with the instability axis, the surface-based instability. And there could be some supercells as well along the tail end of that convective line. I'm going to show you that in the HRRR and the RAP model coming up here next. Here is the forecast wrap for 20Z. So this is 1 p.m. Central Standard Time. It definitely shows the MCS there ongoing across north central Texas and central Texas. And the southern edge of that in south central Texas is where we want to watch for the development of supercell storms. That's where this the southern end of this MCS merges with the nose of this instability axis right here. You can almost see a bit of a dry line here across South Texas with these westerlies and southwesterlies back behind that front that's moving off to the east. And that convergent boundary there down into south central Texas is going to be the initiating boundary for these supercell storms. You can see that the RAP is even showing some supercell storms all the way up until you get to the nose of that instability. North of there, you get more of an MCS, more elevated convection. But this MCS is going to move off to the east across East Texas, bringing with it that southern zone for supercells, approaching the Houston, Galveston area by 6 p.m., but I don't know if the instability is going to make it there. We have mainly east-southeasterly winds so far this morning. You saw that ob just offshore with a 55 dew point. And really, we need to tap into the western, southwestern part of that Gulf of Mexico to get those deeper dew points a little bit further north. But to the west of Houston, closer to Austin, over here in the South Texas Hill Country, Lockhart area, well east of San Antonio, north of Port Lavaca, that's the area where I think there definitely is a chance for supercell storms and even a threat of those isolated tornadoes. And this system's going to bring winter weather here in the southern Appalachians, so I'm thinking about chasing that winter storm out near the Brevard, North Carolina area, maybe riding it out in my car, sampling some of those heavier snowfall rates of 4 to 8 inches. But here you can see the RAP forecast low-level storm relative helicity, and that's also going to be pretty marginal, and that's because of the late maturation of this upper-level system. You get kind of the development of a modest low-level jet across this area that peaks just a little bit above 30 knots, which I think with those east-northeasterly storm motions like this and a critical angle a little bit closer to 90 degrees, a 30-knot low-level jet looks like it's going to be more than sufficient to generate about 150 to maybe 200 meters squared per second squared storm relative felicities here. And the southern edge of the convective line where you get more supercell storms is going to be embedded within that environment. But still, the low-level shear is relatively marginal. We'll just have to see if those storm motions that are a little bit closer to due easterly than we've seen with these recent setups, which are a lot more meridional, I do think that that could be enough to tip the scale in the direction of tornado potential. But there is going to be late arrival of this modified moisture. Dew points in the low 60s are going to be probably the best bet out there across south central Texas, maybe even into the Houston area there where dew points could be right around 60. But now I'm going to show you the HRRR model really quick. There you can see the NAM. We're going to break down some of the high resolution models with this setup. And then I do want to go over some snowfall totals here in the southern Appalachians. Two different systems, one Thursday night into Friday, then another one Sunday night into Monday. That could be bring substantial snowfall over portions of the southeastern U.S. Asheville, North Carolina, Brevard, those areas, you're going to be the lucky big winners from probably both of these systems. Could easily see two storm systems back-to-back dumping multiple inches of snowfall. But here is the NAM forecast evolution for that Vort Max by about 6 p.m. tonight. And here is the HRRR forecast for that Vort. The HRRR shows a bit of a late arrival of that stronger flow to the base of the trough, even by 0Z. This is the, I believe this is the 12Z. Yep, so this is the 12Z HRRR. So this is showing me that there may be a little bit less of a chance of severe weather or tornadoes here across East Texas. This is my very initial glance of the HRRR. And this is already at 21Z, so already at 3 p.m., just a couple hours before sunset. And it looks like there could be a late arrival of this stronger flow to the base of the trough. Really, this trough reaches maturity when this strong flow on the backside of the trough rounds the base of it. That's when you get that cyclonic curvature there. That's when the vorticity of action downstream really maximizes. That's when there's going to be a maximization of that low-level jet as well. Downstream here, you can see how these mid and upper level winds are almost west-southwesterly direction. That's pretty veered, and that's the reason why you have a bit more favorable of a shape to those photographs, and a 30-knot low-level jet should be just enough. And you can see even approaching 40 knots down here, tailing down into the nose of that instability axis, 30 to 40 knots there, and this is at 21Z. So even though you have a late arrival of that stronger flow to the base of the trough as depicted by the HRRR, it still has a nearly 40-knot low-level jet there from Port Lavaca well to the west of the Houston area, between Houston and Austin. Definitely looks like that's where that tornado threat could maximize. And this is a bit of an improvement. I'm kind of surprised after seeing that initial shape and evolution of that upper system to have this pretty robust low-level jet here forecast by the HRRR. Let's see how it evolves. Notice how that low-level jet hangs back to the west of the Houston area. probably some stable air that's from Houston east through the Beaumont, Lake Charles area. Quite a bit of stable air here. We saw that ob that was offshore there in the Gulf of Mexico with only a 55 dew point. So it does look like those deeper dew points are coming in through the far western Gulf of Mexico to the west of the Houston-Galveston area. But definitely quite a acceleration of the low-level jet there to the west of Houston. 40, 45 knots there at a kilometer above the ground. That's probably where that tornado threat is going to maximize, and you can see almost a decoupling of that low-level jet, where a core of the southerly low-level jet lifts off to the east of that vort max, where you have the greatest vorticity of action downstream. More of a veering of the low-level jet here by 23Z by about 5 p.m. to the west of the Houston-Galveston area. That could signify kind of a reduction of that severe weather threat as well. So it does look like there's a pretty narrow window across south central Texas before that low-level jet veers a bit where there could be severe weather. Let's look at these thermodynamics. And I'm going to bring this mic down a little bit closer, try to improve the volume just a little bit because I'm leaning a bit forward. And there's that instability axis here as shown by the HRRR. Test, test, 1, 2, a little bit better audio. There we go. And again, this is a code red live severe weather briefing that we are breaking down here. I'm looking at the pivotalweather.com website right now, breaking down surface-based instability. This is a forecast for 21Z later on today. And really, we're looking for the nose of this instability axis out here to the west of Houston, to the east of the Austin area. That's where it looks like the greatest co-location of surface-based instability and that low-level shear could be happening. I don't like to use these composite indices, but they are a good way to kind of show the best co-location of that low-level shear and the instability. So it looks like generally this area, well to the west of Houston, to the east of Austin, at the nose of that instability, right before that low-level jet really starts to veer to the west of the Houston area. That's going to be the greatest threat for severe weather. This is at 20Z, so this is at 1 p.m. And we can look at the precipitation as well here, composite reflectivity. Kind of see where that convective line or that MCS is located. Here is this mesoscale convective system moving across eastern Texas here as forecast by the HRRR. And you can certainly see some embedded supercell structures that are being hinted at by the HRRR well to the west of Houston. So this is at 20Z at 1 p.m. By about the midday hour, we could already start to see some supercell storms developing out here. This is right at the nose of the instability as well. Pretty marginal dew points, though. Low 60s at best. Many of the, looking at the surface map, a majority of those dew points right now this morning at 9 a.m. are located to the west of Port Lavaca out in this region. So you may want to target really the furthest south portion of that line, but it is hinting at some embedded supercell structures there. Let's try to look at a representative hodograph there in the clean environment. And this is okay, and you could definitely see some negative contribution to the storm relative helicity here between about 2, 3, and 4 kilometers. But really, as I suspected, that veer-back veer is definitely not as detrimental to tornadoes as many people originally thought. Just a little bit of a negative contribution there to the storm relative helicity at those 2, 3, 4 kilometer layer above ground. But as long as you have this big-time low-level shear and you have a storm motion that's a bit further east, critical angle closer to 90 degrees, that can definitely generate enough storm relative helicity in there to get tornadoes. But this is incredibly marginal. Usually we see those big looping hodographs with a lot of storm relative helicity in there as a hodograph that's more favorable for a strong tornado threat. But still, we do have enough storm relative helicity in the lowest 1 to 2 kilometers of the atmosphere here to maybe generate a tornado threat. And all this is driven by those 500 millibar winds being relatively due west to east. Here you can see the mid-levels of the atmosphere, that speed max of about 50 knots, whipping around the south and then the east side of that trough, but relatively veered, and that brings these storm motions a little bit closer to an east-northeasterly direction, and you still maintain that southerly low-level jet with that vorticity of action upstream. Here you can see those relatively marginal dew points that realize out here, about 62. That's what we're going to be looking at, a 68 over 62 type of a profile. More than sufficient, though, to generate strong low-level lapse rate. See how these temperatures decrease with height here in the low levels of the atmosphere? bend that over just a little bit to the right. These are pretty strong low-level lapse rates. That red line is temperature. The rate at which the temperature decreases with height in the low levels of the atmosphere, those are lapse rates, low-level lapse rates. Here's the elevated mix layer, the dry slot coming in the mid-levels of the atmosphere at about 3 to 4 kilometers above the ground. This is going to be enough to steepen those lapse rates quite a bit. So you do have enough CAPE. Thermodynamically, despite the dew points being in the low 60s there, probably going to be more than sufficient to still steepen the low-level CAPE there, those low-level lapse rates. And really, these more westerly 500 millibar winds are key to getting those storm motions closer to an east-northeasterly direction. If this storm motion were a little bit further to the right, you'd really ramp up that wind shear just a little bit more. But that would even bring the critical angle greater than 100 degrees. So this is definitely a unique setup here. And this, again, is the 12Z HRRR that we're watching. Let's see how this convective line marches east just to get an idea of timing. This is at 21Z, so about 3 p.m. And you're already starting to see a bit of a splitting of that low-level jet. The low-level jet is beginning to veer here on the south side of this line by this time at about 21Z. It's almost parallel to that convective line. But remember, too, that these storm motions, instead of being meridional and parallel to that convective line, they're going to be more of an east-northeasterly direction. So these supercells on the south side of this MCS will have a bit more effectiveness at moving off that boundary with an east-northeasterly type storm motion. But as we get after 21Z, notice how this low-level jet begins to veer down here in the open instability axis and become just a bit more parallel to that convective line. I'd like to see a low-level jet that's more southerly, kind of like you're seeing up here over the piney woods of East Texas up toward Shreveport. That's a more southerly backed low-level jet. Down here, though, you have a bit more southwesterly of a low-level jet. But because of those easterly storm motions closer to an east-northeasterly direction, that's a pretty favorable photograph there to the west of Houston. Look at that forecast photograph. Critical angle very close to 90 degrees. Your 3, 4, 5, and 6 kilometer winds down here. More than sufficient at evacuating that rain and the hail from the updraft of this mesocyclone. And quite a bit of storm relative helicity there, despite that veered low-level jet. And all this severe weather threat is driven by a storm motion that's a bit closer to due east. This is east-northeast at 30 knots out there. Pretty favorable photograph here. Critical angle close to 90 degrees. So if you didn't have that critical angle right at 90 degrees, it's very likely that you need a stronger low-level jet to generate sufficient low-level storm relative helicity to get a tornado threat. But this is that 1 kilometer wind, south-southwest wind, getting close to 40 knots. Surface wind due south at about 15 knots. Enough speed shear and a little bit of directional shear there. You can see just a couple of degrees of directional shear to really generate this hook-shaped photograph. Little bit of veer back veer there, just a little negative contribution of the storm relative helicity. But again, as I suspected, and based on my personal subjective assessment of many of these shear profiles, that usually that negative contribution to the storm relative helicity above 2 kilometers is irrelevant for tornadoes, especially as the mid and upper level flow is strong enough to evacuate that rain and the hail from the mesocyclone to maintain a nice clean mesocyclonic updraft. But this is a nice photograph, surprisingly good between Houston and Austin and the HRRR, and that's in this regime here with slightly backing low-level jet, but still a south-southwest low-level jet, 35 to 40 knots out there. I suspect that if we look at these composite indices, you should see a bit of a overlap out here. And that's where that low-level shear overlaps with the instability the best. This is the target area out here. You can see a little bit of surface-based instability lifting up where that low-level jet is a bit more backed. But notice how the Houston area really stays in that stable air the whole entire time. So the Storm Prediction Center brings those 5% tornado probabilities to the Houston area. We'll have to see. I think that convective line, by the time it reaches Houston, is going to be all strung out. It's going to start to get elevated. I think that stable air is probably going to hold across Houston. And notice how this instability really starts to get pinched by about 22Z. By 4 p.m. and after, I think that the tornado threat's going to begin to subside and really get pinched to the southwest of Houston. And Houston appears to maintain that stable air You can look at a forecast sounding here near downtown Houston. And the HRRR keeps those dew points in the upper 50s near Houston, and that's going to be just enough to lead to a little bit of low-level stable air right here. Despite this elevated mix layer just above the ground, this stout elevated mix layer, you still kind of hold that stable air near the Houston area. Probably development of a bit of a stratus stack out there as well near the coastal areas. You can see the hint of cloud cover as well over the Houston area, kind of limiting that. So despite a favorable hodograph in the Houston area by 4, 5, 6 p.m., I think that stable air is really going to mitigate the tornado threat across the Houston area, despite that 5% extending all the way there. So here it is. Let's see what the HRRR shows. And it looks like you could get a couple of supercells down here near the Port Lavaca area by this time, by about 4 p.m. Central Standard Time. But the convective line really starts to mush together on approach to the Houston area. Stable air a bit. Those more marginal low-level dew points near the Houston area and to the Sabine River are going to be an issue. Trying to break down the severe weather threat for the Houston area. This is so by about 6 p.m., 5 to 6 p.m., that convective line begins to approach downtown Houston. But notice how it begins to bleed together a bit. You get kind of a loss of that surface-based convection here on approach to Houston. That's because of that stable air. Those dew points are going to be holding in the low 50s, and it looks like that instability axis gets pinched off to the southwest of southwest of Houston, down toward Port Lavaca. And by this time, by 5 or 6 p.m., there could be a couple lone tornado warnings down near Victoria, Port Lavaca area down there, and just this convective line approaching the Houston area by 5 to 6 p.m. Look at that. Look at the dew points get pinched down into the southwestern portion of the Gulf of Mexico there. Definitely gets pinched well to the southwest of the Houston area. Pretty meager moisture hanging on. And see that stable air coming in here off the Gulf waters with those more east-southeasterly winds holding up here near this portion of the coastline. That's why I think that this severe weather threat is going to be to the west of Houston or bust. Maybe down toward Port Lavaca late by 5 or 6 p.m. But it looks like a 2, 3, 4 p.m. type of an event to the west of Houston if it does materialize out there. There does seem to be agreement on that window between the HRRR and the RAP. Looks like it's going to be well to the west of the Houston area. That's at 21Z. This is at 20Z. And that's why I put that target area well to the west of Houston last night. And it looks to me like the models haven't changed much with this instability axis. But the HRRR does show some 64s up there, surging up to the south side of that convective line. That's going to be more than sufficient to generate that tornado threat. NAM agrees, 63, 64, 63, 64 type dew points well to the west of Houston, kind of holding that stable air around the downtown Houston area, that stable air almost getting funneled up Galveston Bay there as depicted by the NAM model. That's at 21Z, and then 3 hours later, the NAM also shows that stable air hanging around the Houston area down through the Sabine River area, and most of that instability and greater dew points are held to the west of Houston, pinched off over the western Gulf of Mexico. We'll have to see if that happens. I think that's exactly what is going to happen, though, with these short-range models basically in agreement with that. Looking at the 3-kilometer NAM also shows those dew points really getting pinched off down here closer to 5 to 6 p.m. Port Lavaca area. Could certainly get some severe weather, maybe some water spoots coming ashore. And then this system will gradually head toward the southeastern U.S., and that's when we got to watch for the snowfall potential. There's also a potential for several inches of snow over the higher terrain with this system, with this vortmax passing over the Ozarks And we do have a winter storm warning that's in effect for these Ozarks, given the passage of this vortmax tonight, just to the south of the Ozarks, and aided by the higher terrain. This is a decent track for big-time snow here across the Ozark Mountains, and that's how we have the winter storm warning tonight through tomorrow morning there. Could get 3 to 5 inches of snow across the higher terrain of the Ozarks, especially above 1,500 feet. Up there with that cold bowling ball of an upper level system moving through. And then the threat shifts to the southeast Thursday night. Snowfall arrives Thursday night here. Coastal storm develops downstream of this. A lot of vorticity advection there as well. Lift in the mid-levels of the atmosphere leading to those dendrites across the southern Appalachians here out ahead of this vortmax in the southern stream. This is the 3-kilometer NAM. I know not a lot of NAM fans out there, but this thing nails it. So this is Thursday night. Heavy snow arrives in the mountains of western North Carolina. Heaviest snow just to the west of Asheville in the higher terrain. Asheville, though, also gets hammered. These locations in the higher terrain across northern South Carolina also get quite a bit of snow from this. This is about 9 or 10 p.m. Eastern time. Getting a little bit closer to midnight, 11 p.m. Start to get some convective elements to the snowfall here across the mountains of North Carolina, even into those mountains of South Carolina as well. Look at that, the heaviest snow coming in there after midnight, 2, 3 in the morning out here. Smokies are going to get hammered from this as well. Probably some thunder snow. I wouldn't be surprised to see some thunder snow up there. I may spend the night in my car out here in the west, in the mountains of North Carolina. And that snow comes down into Traveler's Rest, these locations in upstate South Carolina by 12Z as this coastal low gets going off northeastern South Carolina there. Look at that coastal low ramp up, all the convection associated with it. Look at that snow coming in here to upstate South Carolina. This is by Friday morning, late morning, 15Z. Western North Carolina still getting hammered. That snow moves into the Charlotte area as well. So this looks like it's going to be a pretty big snow event. Look at that lifting off to the northeast, brings that snow further north, even into the mountains of western Virginia. So you're talking about double-digit snowfall totals here, and that includes the border of South Carolina and North Carolina, just to the north of me, near Hendersonville. Those locations, 13 to 15 inches of snow up here as well. The Smoky Mountains are definitely going to get hammered by snow. This is the 3-kilometer NAM, which, in my experience, limited experience here, seems to do pretty well with these Southern Appalachian events. Let's see what the NAM is showing out here. Regular NAM. Doesn't quite resolve the mountain terrain quite as well, but definitely shows a lot of snow here. Up a little bit further north, it doesn't show those double-digit snowfall totals near the border of South Carolina and North Carolina. But that area definitely gets a little bit of an enhancement of the snowfall, especially with these coastal low setups, kind of the eastern side of the Appalachians. Sometimes they'll get a bit more. Yeah, this is the latest 12Z 3-kilometer NAM. Snow maps here, and I'm a big fan of the NAM. The NAM doesn't get enough credit for just nailing event after event. The 3-kilometer NAM and the operational NAM here. This is probably the area I'm going to target, just outside of Pretty Place, South Carolina, maybe up toward Brevard, North Carolina, maybe west of Asheville. Probably will sleep in my car and experience this winter storm. Live stream it. But thank you, everybody, for tuning into my weather reports today. I'm going to be breaking in live as this severe weather event happens this afternoon, breaking down the radar data, the tornado warnings as well. And then I'm going to be chasing this winter storm system live for Radar Omega. We're going to be streaming some live data as well during this event. Definitely a good opportunity to interact with the app and see some of the real-time conditions happening. I'm going to Dominator 4 is going to be streaming real-time wind data back to the Radar Omega app as well during this event. Pretty active pattern here for the southeastern U.S. for snow. The next wave comes in Sunday night into Monday. And look at this, several inches of snow all the way out toward the Charlotte area as well, depicted by the NAM. Could easily get a 3 to 6 inch snowfall event, maybe even more than that. Double-digit snowfall totals for the southern Appalachians, the higher totals here. But notice how the higher totals here are on the eastern side of these southern Appalachians, and that's because this is more of a coastal low event, with that coastal low ramping up off the coast of the Carolinas before it goes out to sea. This is why we shot those before shots from Pretty Place up here in upstate South Carolina with the drone, just to get those before and after shots of this beautiful terrain down here in the southern Appalachians, including the foothills here, the Piedmont of the southern Appalachians. Beautiful place to live. Even hinting at some lake effect here off the Finger Lakes with that northerly flow here across western New York. And that's what's they definitely can see that on radar this morning with an enhancement of those snow bands with that wind parallel down the deeper Finger Lakes here. They're narrow, but they're very deep, so that prevents them from freezing over, and they stay relatively warm. So when you get these cold northerly winds coming down the spine of those, you can definitely get some heavier snow down here on the other side of those Finger Lakes. Incredible phenomenon to witness. So thank you everybody for tuning into my weather reports. These are made possible by the Facebook supporter community. And this is the system that we're going to be watching today, this potent Vortmax. The best thermodynamics kind of pinch off to the west and to the southwest of Houston. That's why we have this target area to the west of Houston. Probably should expand that a little bit further north and east, but definitely between Houston and Austin, that looks like the greatest threat for tornadoes. And that window, I'm going to expand that a bit earlier, 1 to 2 p.m. is when that window could begin across the northwestern portion of that target area, and then extending off to the east. Then that instability pinches off to the southwest of Houston. But thank you everybody for tuning in to my weather report. This is a code red weather report here. Go back to regular colors. There you can see a picture that I got my mom for Christmas years ago of the Dominator intercepting a tornado there on the wall back behind me. All kinds of tornado artwork here at my mom's place. But thank you everybody for tuning in. If you live especially west of Houston, between Houston and Austin, keep an eye on my weather reports. Stay tuned to those severe weather alerts. Stay tuned to the Radar Omega app. Because I do think that there definitely is a chance of supercells and tornadoes on the tail end of that convective line, especially to the west of Houston. So have a great rest of your morning this Wednesday. I'll be back live this afternoon as this severe weather event ramps up. Never stop chasing.